The power of the wind. It sounds almost like poetry, but for centuries man has been using wind power to expand his horizons. In the great sailing vessels which carried explorers to the New World, and in windmills along the lowland coast of Europe, especially the familiar Dutch windmills of the Netherlands. Today, we're on the verge of another great leap in the use of wind power, this time aimed at supplying a significant percentage of the nation's energy. Since 1973, the National Aeronautics and Space Administration has been pioneering a major effort to turn wind energy into electrical energy. The Department of Energy and NASA, together with partners in the private sector, have been developing sophisticated windmills called wind turbines to accomplish the goal. This television program, Those Magnificent Wind Machines, will trace the dramatic evolution of the NASA wind program from its first experimental wind turbine at Lewis's Plumbrook facility near Sandusky, Ohio. You'll meet a sailboat maker whose company now makes blades for these wind turbines. Travel to Block Island, Rhode Island, where NASA and the Block Island Power Company proved that wind turbines could actually supply power to an electrical system. And finally to Washington State for the startup of the largest, most powerful wind turbines ever built. When did work begin on wind turbines here at Lewis's Plumbrook facility, and what was the motivating factor?
We started back in 1973, Hugh, and we got into wind energy with NASA using its skills in aerodynamics, and structural dynamics, and systems and controls. We designed this machine, and the machine actually started operation in September 1975. And some people realized there were eventually going to be energy shortages, and we took a hard look at solar energy. And wind energy is a form of solar energy, and at that time we started to make some evaluations on, is wind energy practical? Could it make energy for the U.S.? We felt there was such a good potential energy source there that we wanted to take a hard look to say, hey, could we really make these things cost competitive? And it turns out that at the Lewis Research Center we had the right combination of skills to address this question. First of all, a wind turbine has large blades. These are aerodynamic blades, so we have engineers that understand wings and propellers and those types of things. And windmills, to be cost effective, we knew had to be very large, take a lot of energy out of the wind. And that requires structures and the stress analysis and the systems analysis and the controls and so forth. So we had a good mix of engineers to put on this problem.
What do we have now here at Plumbrook?
Well, what we have here is an experimental machine. The Mod Zero wind turbine, what most people would call it a windmill, is really an experimental test bed. Now this machine is 125 foot in diameter, 2 blades, only makes 100 kilowatts. We use this machine to test blades, particularly low-cost blades, to make sure that the new components are reliable and safe, and particularly the emphasis on low cost. And everything we test here at this machine is applicable to the design of all the large wind turbines that are now going out and being used.
What is in this control room?
Okay, in this control room are all the necessary devices to operate this machine, to start it up, to control it, to shut it down, and more importantly, to take a lot of experimental data. Now, you don't have a control room like this that goes with every machine we put at a utility. Like I said, this is an experimental test bed. So this room has a lot of capability to take data. When we try new ideas, we have to evaluate to see, are those new ideas working the way we thought they were? Are we making more power? Are the cyclic loads being less so that the blades will last longer? This control room has all the capability to record this automatically.
I noticed that the blade we now have looks like a wing, not like a fan.
Right, and they have 2 large wings, and we refer to them as blades. And it turns out that, well, that in itself raises an interesting question, because we only have 2 blades, and almost everybody says, well, why doesn't it have 3 or 4 or 5, or like the old farm windmill with mini blades, like you say, a fan? It turns out that under a lot of analysis, the most cost-effective way to build these is only to put 2 blades on them. And that turns out that you get the most energy for the money.
What's inside the hub of this turbine?
Well, up on top of this turbine is the machinery that actually generates the electricity. Those 2 blades take the energy out of the wind. And in the hub then is where these blades, where they're held on to, and they drive a shaft that drives a gearbox, similar to the gearbox in your car, and it takes this low revolutions, so many 40 revolutions per minute that the blades go around, and puts that up to 1,800 revolutions per minute, and that's what an electrical generator likes to run at.
The experimental work accomplished at the Lewis Research Center Plum Brook facility showed that these modern wind turbines were feasible, although more research on the all-important and costly blades remained to be done. Pat Finnegan is part of the NASA team trying to reduce the cost of the blades. Through the work at the Lewis Research Center, what materials are now being used to manufacture wind turbine blades?
Okay, we currently make blades out of 4 materials: steel, aluminum, wood, and fiberglass.
It appears that we have one blade right here that's made out of more than one material.
Yes, that's correct. This one contains steel, wood, and fiberglass. And the main part of the material is made out of steel, and the most interesting part is that the steel is a steel utility pole.
An ordinary utility pole?
Yes, right. It's a very low-cost way to build a blade.
When we get down to the length of the blades that are now being tested, how long are they?
Okay, the smallest blades in the large wind turbine class are about 60 foot long. Okay, we have blades that are operating now that are 150 foot long, and we have blades on the drawing boards which are 200 foot long.
200 feet? That means it's going to be a 400-foot total diameter?
Yes, right. It'll be the largest wind turbine in the world by far.
When you're testing blades, for instance, these fiberglass blades, what are you looking for in the tests?
Okay, these blades will be put on field test wind turbines. We will be measuring the life of the blades, the durability, and the effect of the environment on the blades.
Those are the things that you're looking for now at this stage of testing?
Yes, right, in the stage of testing. And in addition to that, we're also doing work to reduce the cost of the blades, increase the aerodynamic efficiency of the blades.
In testing wind turbine blades such as this one, what properties are you looking for?
Okay, we're interested in 4 main properties. The first is that the blade should be structurally sound. The second is the blade should be low cost. Thirdly, it should be aerodynamically efficient. And lastly, it should be easily maintainable.
At this test stand, what process is going on?
Okay, what we are doing here is we're trying to determine whether or not this blade is structurally sound.
How do you go about doing that?
Okay, we do that by pulling on the blades with these winch devices to simulate the force that the wind normally puts on the blades during normal operation.
You literally pull down on the blade to bend it.
That's true.
Do you destroy the blade or break it?
No, we don't. We don't destroy it. We don't damage it in any way. What we do is when we apply the force equal to the wind force, we measure the deflection of the blade. If the blade bends in the manner in which we predict, then we know the blade is structurally sound. If it bends more than this, then there's a possible weakness in the blade.
This wind turbine blade made out of wood is manufactured by your company, a sailboat company. How did a sailboat company get involved in wind energy?
Back about 3.5 years ago, I came down here to Cleveland to give a boat building seminar, and several of the fellows who work here were interested in boat building, knew I was coming, and suggested that I drop by and talk to them about wind blades.
What technology had you developed in boat building that you were able to translate or transform into the manufacture of a wind turbine blade?
Over a period of about 10 years, we developed a wood composite, which is similar maybe to fiberglass, but we use wood fiber in relation with a modern epoxy resin. And this we refer to as a composite because about 25% of the weight of this blade is indeed plastic.
This blade then is not solid wood, it's hollow on the inside?
That's correct. That's correct.
And then the wood is in there in layers with this epoxy rosin?
Right.
How do you go about relating your company to the National Aeronautics and Space Administration? What's the relationship?
Right now we serve as a contractor to them, and we perform two services. One is to do research and development on blades, both smaller than this and larger than this. And then the second is to develop a manufacturing method and the technology in manufacturing so that we can build these blades in a cost-effective manner to make wind energy cost-effective.
Is your company a large company?
No, we're quite a small organization, about 30 employees.
With the Plum Brook facility still providing important data, and contractors like Meade Goujon contributing their expertise to the wind program, NASA needed to prove that wind turbines could actually generate electricity in utility systems. The small Block Island Power Company in Rhode Island was one of the utilities chosen for this critical test. How did the Block Island Power Company come to be involved in this project?
The way the Department of Energy operates in the large wind turbine program is to put out what they call program opportunity notices to the electric utility industry. Utilities who are interested in working with the government on a cost-shared basis to explore the possibility of wind turbine-generated electricity would respond to that program opportunity notice and volunteer a site for a wind turbine. And one of the companies that responded back about 1977 or so was the Block Island Power Company.
What sort of problems were you looking to solve? What were you trying to prove? What were you trying to learn when you decided to put this wind turbine here on Block Island?
Hugh, Block Island is a kind of a unique place for us. Block Island is a totally independent, very small electric utility, and it has no interconnections. No electrical cable runs between this island and the mainland, so that all of the electricity generated on this island comes from diesel-fired motor generators. And we wanted to learn how the wind turbine could work in a small grid like this, where the wind turbine is capable of supplying at times almost 40% of the demanded power in the system. What we have proven is that in a small utility like this, where the wind turbine can supply a significant amount of the electricity under certain conditions, the wind turbine can be phased in and out of the system. We can bring it up online and plug it into the system and take it offline very easily. And that was one of the major things that we wanted to prove here.
What sort of problems did you run into in putting it here and getting it into operation?
Well, one of the problems that we are having is, as I mentioned before, the machine can supply a significant amount of the power in the system. And so when you have the machine online, when the winds are up, the diesel motor generators that normally supply the power have to be somewhat throttled back. And so we're running into a problem where they are not running at their most efficient set point, so we're not saving as much fuel as we ordinarily would.
That's a solution you haven't reached yet.
That's correct. We're still working that.
Any special problems that you've had to find special solutions for?
Well, one of the problems, of course, that we had was the problem with television interference. If you put a wind turbine into a site where there is television reception, you're essentially putting, in this case, a 125-foot diameter wing up in the air that will reflect those television signals. And whether a house is between the machine and the transmitting stations, or whether it's off to the side, there still will be some television interference produced, and it's a kind of a flutter that is the same kind that airplanes make when they fly over your house. Yeah.
What did you come up with as a solution?
Well, in order for us to run the turbine, in fact, it's kind of humorous, I think, in a sense, because when we first put the machine in here, we were restricted from running during prime television viewing hours.
How were you restricted? Just by the community
That's
saying
correct.
They didn't want you running?
We agreed to do that so we wouldn't interfere with the television reception at that time. In the meantime, what we did was to install a cable network here on the island, and so now the folks here are getting about 12 channels of cable television.
Is that what's going to have to be done at every installation of this sort?
No, Hugh. This is a siting consideration. But many of the best wind sites where we'll put large wind turbines in the future will be remote. That is, they'll be away from people where television interference won't be a problem.
What sort of reaction have you had from the power company to this year and a half?
Their reaction generally has been good. They have been very, very cooperative with us. They have had to hire extra help in order to make the measurements and so on and produce the engineering data that we need from this machine, so that they have been very helpful. They secured all of the building permits that were required to put the machine in. They have done everything that they could to accommodate the program.
How is the power generated here at the Block Island Power Company?
By diesel, which is now 100% dependent upon the diesel fuel that we have to purchase from OPEC and so forth.
Now, is that the only way you generate power here now?
No, we're using the wind as an assist.
How has your view about wind power changed, modified, or stayed the same as the price of fuel for those diesel engines went up?
If we can get more use of the wind turbine and also be able to see a reduction in the fuel that we're using for the diesels, I think this will be beneficial to our customers in a great length.
365 days in a year. How many days a year does the wind blow here on Block Island enough to run a turbine?
I would think in the neighborhood of 200, 210 days.
Out of the 365?
Yes. Yeah, some of our wind conditions here will be too low, and in the winter months we will find days where the wind velocity is too great for the turbine to run.
But still, 2/3 of the time?
I would think so, yes.
Mr. Renz, as the price of diesel fuel has increased over the years, has your attitude changed toward wind-generated power?
Yes, it has. As the cost of fuel went from 15 cents to over $1 that it presently is, our interest has increased 3- or 4-fold simply because of the cost of fuel.
Does this particular wind turbine create a savings to your company?
It really isn't as much of a savings as it is an experiment at this time, and as we work out the problems of fuel control, we expect substantial benefits because it is generating a lot of power.
As far as not being a savings is concerned, why do you keep it then? Do you think that it's going to work out?
Well, particularly last month we had one of our highest savings that we have had recently, and we're working on the actual fuel consumption that is saved because of the generation. It may sound complicated, but we are involved with a penetration that is sometimes as much as 50% of our power.
Does that mean 50% of your customers are having wind-generated power?
Yes, that's true.
You operate an electric utility with less than 1,000 customers. You come in contact with people who operate electric utilities with tens of thousands of customers. What do you tell them?
Well, the large utilities, one large utility we are basically in a partnership with, they have over 1 million customers. We give them the information. They're on the mainland in Massachusetts and Rhode Island and parts of New Hampshire. Their engineers come here and they watch this, and my understanding is some of the large utilities now are getting involved in large wind turbines, at least 10 times larger than this.
If they're looking at it, that must mean that they think there might be something there.
Yes, and the comments that I've gotten from them and talking to them, they're surprised at the amount of electricity we're getting from this. So I think as time goes on and we continue to prove that it's a worthwhile project, their interest continues to increase.
What's been the community reaction to the wind turbine?
At Block Island here, the community reaction has been good. There has been, again, a slight problem because folks were under the impression that when the wind turbine was installed here, it would significantly reduce the amount of their electric bills. That has not happened for a number of reasons. The wind turbine is an experiment. It doesn't run all the time. The amount of power that it actually generates and the amount of fuel that it saves is very small compared to the total usage on the island. So that means that it would not really show up significantly in the fuel charge in the electric bills. And that has been a disappointment to some of the folks.
Would you like to see them continue the experiment?
Oh, certainly. I'd just as soon see them even expand it and try to harness the wind power in different ways. They have other designs from what I understand.
I think it's a good idea. They've had some problems with it because it's been interfering with radio transmission and television transmission, and as a result they had to pay for the entire island to go cable. But I think it's good that they're moving towards something like that, which is making us less dependent on foreign oil.
The Block Island wind turbine helped reveal the potential for wind power. This work at Block Island showed that these sophisticated wind turbines can be an effective, environmentally safe form of power generation. But Block Island's wind turbine is still primarily experimental, with a big test still ahead. Could this new technology be developed to provide power cheaply enough to be cost-effective for major utilities? Is wind power now a cost-effective way of producing electricity?
Wind power today is right on the verge of being competitive with alternatives. We now have a number of machines operating around the country, experimental machines in Hawaii, Clayton, New Mexico, Puerto Rico, Block Island, of the same type that you see here today at Plumbrook. We also have 3 very large machines built by the Boeing Company connected to the Bonneville power grid in the state of Washington. Now those machines, unlike this, which is only 125 feet in diameter, the 2 blades are 300 foot in diameter, and they each generate 2,500 kilowatts. Those machines just recently came online. Those machines, if they were sold today and put up, generate electricity for about 8 to 10 cents a kilowatt hour. Now that's not competitive what we pay to CEI here today, but many places in the country where oil is primarily used to generate electricity, that is competitive.
Then power companies, electric power companies, are now looking at the possibility of wind generation.
Very seriously. The Hawaiian Electric Company on the island of Oahu has signed an agreement with a company called Wind Farms to purchase the electricity from 20 large wind turbines. This would be 80 megawatts of power. The Pacific Gas and Electric Company has signed an agreement for up to 80 or 90 megawatts of power. Southern California Edison in California has recently asked for proposals from windmill suppliers for a number of these large machines. Now they haven't awarded any contracts yet. They're all they're very interested, and the wind looks like it may very well be competitive and have a lot of potential, and things are starting to go, but these 3 large machines that are operating in the state of Washington, the utility companies are watching those closely to see how well they perform.
For wind power to become a major source of domestically produced electrical energy, very large wind machines, which can produce more than 10 times the power of the Block Island machine, will have to become common sights on the American landscape. Large wind turbines in clusters known as wind farms would be needed to accomplish the goal. The first wind farm has been placed in Washington State by the Department of Energy, NASA, and the Bonneville Power Administration.
We'd like to welcome you all here to Goodnoe Hills, because today we're holding ceremonies that mark completion of work on the world's first wind energy farm. I, Donald E. Coons, Mayor of the City of Kennewick, Washington, do hereby proclaim Friday, May 29th as Wind Energy Day. 3, 2, 1, mark.
You'll notice that we have the 3 turbines as a cluster. This is the first time that 3 large multi-megawatt machines have been clustered. With these various legs of the triangle throughout the year, as the wind blows from each of the various directions, we will be able to evaluate the effects of one machine shielding another machine. This is very important because utilities, with the price of land in today's market as well as in the future, we would like to pack as many machines on a plot of land as we possibly can. The machines, when they are running at their rated condition, each one would generate 2,500 kilowatts, so the three machines running collectively would generate 7,500 kilowatts of power. As far as the amount of power and energy that's produced, this translates into serving approximately 2,000 to 3,000 homes in this particular area. From the standpoint of costs associated with the energy being produced by these machines, we talk about this machine as being a commercial model. And in that context, I mean, we've designed this machine with manufacturing capabilities in it, production line type assembly. In that context, when the 100th unit would come off the production line, the cost of the energy produced by that particular machine would be less than 5 cents per kilowatt hour.
The first wind farm in Washington is certainly an historic stage in the evolution of the American wind energy program and the national effort to be energy independent. In the near future, travel across the United States may provide the additional thrill of 100 turbine wind farms with 300-foot blades turning in the transcontinental breeze.